solid. So before with surface area, if we were taking this prism here, triangular prism, surface area, we were thinking about this net that comes out and thinking about each of these different parts that make it. Now when we talk about volume, we're talking about actually filling this up. How much can we fill up to this brim? And to measure how much fills up, we measure it with cubes.
We've been doing surface area, which is just like the surface outside. But volume is basically like the space inside. We're trying to measure the space inside of like the shapes.
All right, so we pulled out this cube, or this prism, at the beginning of the chapter. We talked about surface area. We counted how many shapes were there on each side. But now if I think about volume, it's thinking about how many of these cubes make up the whole amount. So how many cubes are there total here? How many cubes are there in each layer? 1, 2, 3, 4, 5, but then it's 2 rows, so there's 5 and 5, which makes 10, and so it's 10, 20, 30. Okay, so there's 30 cubes here, and that's what we're talking about, is like actually how many cubes fit in here. So when we measure with cubes, that's really what we're asking, is how many little cubes could fit inside. Okay, so we say it with cubic units, is how we say it. And then the way that we write it is we write it with units. And then instead of that squared, we do it with, does anyone remember what number represents cubed? The 3. So this is how we write it. Because we're actually measuring how many little cubes can fit inside. All right, today we're doing volume of prisms. So our formula today is volume equals, we use capital V for volume. And then we have capital B times H. You see this capital B quite a few times now. What does this capital B stand for? Good, not just base, the area of the base. And H stands for height. And that's our height of the prism, not the height of the base. Remember, we might see that height a couple times. We might see it in that area formula, but then this height isn't that same. All right, so per usual, I'm going to use 2 colors, one for area of the base and one for my height. So if you want to grab 2 colors, you can. I'm going to use green and purple. And then you're going to get a glue-in. Your glue-in should fit maybe on this one page. If it doesn't, you might need to cut the bottom one off and glue it on the next page. Mine fits on my page. Usually I take up a little bit more space than most people. So you can glue in on the left or the right side. Doesn't matter. Alright, so get that glued in, and then if you wanted to grab 2 colored pencils, I'm going to use blue and, I'm sorry, not blue. What color is that? Green. Green and purple today. Alright, we're going to do 3 examples here because a big part of today is identifying what shape we have as the base. If we can't identify what shape the base is, then we're going to really struggle through this idea of finding our volume. You were here already. Where did you go? Alright, so as we take a look at this first one, we have a prism here. Remember, prism means that we have 2 congruent shapes, one on each end, and then they're connected by rectangles. So as we take a look at this first one, what type of prism are we working with? What is our base shape? Yeah, a triangle. So this is our triangular prism. And we need to find our capital B and our lowercase h. Those are the 2 things that we're looking for in each of these. So for a capital B, when we look at a triangle, we're looking for, how do we find the area of a triangle? What's our formula? Triangle is half base times height. All right, and as we take a look at our triangles, we're looking for that 90-degree angle for the base and height. So where do we see that 90-degree angle in our triangle? Kind of hidden. It's in this, or I don't know if it's hidden. It depends on how you look at this. To me, it's like kind of on the back side there. That's that 90-degree little box there. So our 2 parts coming to that 90-degree angle, we have 6 and 8. So we're going to do half of 6 times 8. That we could probably do without a calculator. What's half of 6? 3. 3 times 8? 24. All right, now for height, though, this height is different. Remember, this is our height of the prism. So we're not going to use 8 here. For this height, we're looking at that space between the triangles. So if we look and see, if we're trying to connect one point of a triangle to the other point, we can take a look. This would be a height here. That could count. But these are the same all the way around the outsides there. So how much is that height going to be? Yeah, 7. It's the same as this top one. So we're connecting those triangles. So our height is 7. So what we're thinking of here when we do this area of base times our height is it's just like how we did with this prism that we had, this cube, this rectangular one. We counted how many there were in the base. There was 10 cubes in the base, remember? And then we counted it by layers, 10, 20, 30. We did 10 times 3 for our height. So our base is 24, but we're doing like 7 layers of 24. So for our volume, we're going to say V equals our base times our height. So our base is 24 times our height, 7. I don't know what that is off the top of my head. Open up my calculator real quick. 24 times 7, 168. This one we're measuring in MI, miles. But because it is volume, we're measuring in cubes. So we're going to put that 3 with that miles. Cubic miles. Alright, next up we have this next prism going on. What kind of prism is this next one? What is our base shape? What's our base shape in this next one? Yeah, a rectangle. This is a rectangular prism. All we see here are rectangles. So that tells us it's a rectangular prism. There's sides that are rectangles and the bases are rectangles. We don't have that shape that's different. So this one is our rectangular prism. Okay, and again, what we're trying to find here is we need our capital B for area of the base. And we need the height of the prism, lowercase h. So as we think of the uppercase B, we need to know, how do I find the area of a rectangle? What is my formula for a rectangle? Yeah, base times height. Which gets a little goofy because this base, we're not talking about this base anymore. We're talking about the base of just the rectangle. So it's like we're going to zoom in. We're only looking at the base now. Okay, with a rectangular prism, you can choose any of them as your base. Based on what you pick as your base, that might change your height. I'm going to do this one with those squares on it. So this is going to be my base here. To me, that's the bottom, so that makes sense to me. So as I look at just that rectangle now, I'm going to ignore all the other parts. Just zooming in on that rectangle, what's the base and height of that rectangle? 7 and 6, yeah. So 7 times 6, which is 42. So when we do that capital B, it's like we're going to just focus on just the shape. That 2D shape. We're not going to think about the 3D-ness. We're not going to think about how we can touch it, we hold it. It's just that shape. It's just the rectangle. Now as we take a look at the height, this is the part where now we zoom back out and we say, okay, there's two bases, kind of one on top, one on bottom in this case. What's our space between those bases? And if we're not sure, you can always start at the corner of one of the bases. So as how I highlighted it here in green, I can start at one of the corners. I'm thinking going up from that corner to the next one. Okay, so that would be my height. And in order to find that, I can go to any of these other corners and find the same length. And we see our height is 4. So our last step we're going to say is volume equals, so capital V for volume, area of our base times our height. And what's our area of our base? 42 times our height, 4. don't know what that is off the top of my head, so I'm going to grab my calculator. 42 times 4, 100. What? We got the same answer. That's crazy. You guys, I actually really didn't know that was going to happen. You guys are probably like, Miss Merrill's acting crazy right now. I didn't know we were going to get the same answer. That's kind of cool. All right, 168 cubic feet. So now we're saying cubic feet instead of square feet because we're actually talking about how many cubes fit inside. So even though I had two completely different prisms here, we have one that's a rectangle base and one that's a triangle base. We can fit the same number of cubes inside, 168 cubes. Okay, you guys are supposed to be like, oh my god, that's amazing. Ready? Let's try it. Oh my god, that's amazing. No one? Okay.
Oh my god. Amazing.
Thanks, Mr. Kwan. I think it's really cool. What if this last one turns out to be 168? You guys, I didn't even plan that. It's not. I'm pretty sure it's not. But maybe. Let's find out. Alright, as we take a look at this last one, what kind of prism is this? Going nuts. What's our base shape in this one? Starts with a T. Trapezoid, yeah, we have a trapezoid here. So remember, trapezoidal is what we say there. It's kind of a weird word. Trapezoidal prism. And for our trapezoid, we're looking at that part where we have two parallel parts going across, and then we kind of have those diagonals going out. So we're looking at it for a capital B and our lowercase h. Alright, for a trapezoid, this one, the formula is a little bit different. So to find the area of a trapezoid, you're going to do your best for a trapezoid there. Half times, does anyone remember what's the next part? Height. And then in parentheses, we do base 1 plus base 2. Alright, so you don't have to write these formulas every time, but it's just helpful for us to remember that these formulas change based on the shape of the base that we're working with. Alright, so we're going to have half, that's part of the formula, times, now this h, I want the height of the trapezoid. So again, I'm zooming in, I'm thinking about only this green shape, I'm ignoring everything else. What is the height of our green shape here, our trapezoid? 4.3. And then we need our bases. Our bases are the parallel parts. So we can see one base, for most of us we see is our 5. But we're struggling with a couple of us to find this top base. Is this top base going to be 6 or 10? Yeah, 10. So if you need to write that 10 there, just to remind yourself, we're always looking across to see our congruent parts because we have rectangles. So 5 plus 10.
I do have some questions. There's some students who had some questions yesterday. Like, why is the height not 5, but we use 4.3 instead?
Good question. Can somebody answer that? Why are we using 4.3 as the height in this one? So it has that dashed line. What else? The 90 degrees. That's the really important part, I think, is that 90 degrees. Dashed line is there to tell us that's part of that, so it's kind of part of that 90 degrees. Okay, 90 degrees, we measure height. Remember when you go to the doctor, does the doctor want you to just slouch and take your height? Yeah, the doctor wants you to slouch. They say try to not stand up straight. Just make yourself a little shorter. No. Okay, to get your height, you have to stand up nice and tall, nice and straight, so that's where we get that 90-degree angle from. Good question. All right, I don't know the answer to that, so I got to use my calculator. I'm going to use Desmos now, because that's more than just multiplying. So 1/2 times 4.3, parentheses 5 plus 10, and we get 32.25. And we'll leave it as that for now, 32.25. Don't need to round it quite yet, because we might not need to round it in the final answer. All right, now this height, though, this height we're thinking about, okay, now if the trapezoid was put on the bottom. Right now, when I look at this trapezoid, to me it kind of feels like it's like a front. The trapezoid's like in the front and back. That's the way I kind of see it. Okay? And we need to think about if the trapezoid was rotated so that trapezoid was on the bottom, it was on the floor, how tall would this prism now be? So we're kind of rotating it down. And so that height has to be between the trapezoids. And kind of that trick to find our height is we go to our trapezoid, our highlighted part, and we just find any corner of the trapezoid and we're following that across. So that would be our height there. And if that part's not labeled, if I follow that around, yep, our height is 6.
So just like Ms. Mara was saying, so imagine this is the trapezoid and this is the base. Imagine you're rotating it downwards, so the height would be the sides. Okay, that's in between the two bases, the top and the bottom.
All right, so last step then, once we have those identified, is to do our capital B times our H, area of the base, times the height of the prism. Area of the base is 32.25 times our height, which is 6. And, oh, we don't get 168. How disappointing. Would have been so cool. We get 193.5. Anyone want to take a stab at how you would say this? 193.5 what? You're not using square this time. Cubic. Good. We say cubic meters. Squares for area. We use cubic when we do volume. All right.